So I'm using my phone here to take a look at my screen. I just happen to have Google Antigravity IDE up and running. Is right there. Arduino Control was the name of the program. I apologize for the messiness of my desk. But as I mentioned before in the slides, it's fairly straightforward. I have an integrated development environment up and running here. And at the moment, I have the Arduino firmware. I know I mentioned it was C++, that's the language. But in Arduino speak, it's called an INO. And then in there, this is the actual commands to have the Arduino talk to a variable resistor that acts as a volume knob and a light emitting diode. So if you speak Arduino C++, it looks fairly similar to anything you may have seen before. It's not very large. And everything is very explanatory. After working with this for a while, it works out pretty well. Right next door to that is the controller PY. This is the Python code. The Python code is in the same editor. Now this is Python as opposed to the C++. It's a little bit longer. It actually runs the program, if you will, or runs the server, and makes all the magic happen between the computer, my desktop, which is sitting in the corner back there, my desktop and the Arduino board. And then the knowledge, what we actually view in our web browser, is the JavaScript, and it's called main JavaScript up here. And this is JavaScript, and gosh, they all look similar. In fact, if I rapidly give everybody a headache and just switch between Python and C++ and the JavaScript, it's very difficult to tell that they're different other than they're all computer code. But this is the JavaScript over here, and it looks very, very similar. This just happens to describe to the computer what it should look like user interface wise. You'll notice that the JavaScript is actually the longest document, making it look pretty as opposed to the actual ones and zeros of how to make this thing work. Down here below, a bunch of things popping up. Down here below is the actual Arduino that's working right now. This guy is just the power supply. I can turn the whole system on and off. This is my volume knob. And this is the light emitting diode. It's yellow. It also has to be the same color yellow as the standard LED light emitting diode that's on the Arduino itself. So here's my little tiny Arduino. And it runs through a USB through this crazy cable over to the USB-A port over there. So to make this work, it's just a program. What I need to do is I need to tell my environment to open up a command line. This is Linux. So a new terminal, and down here is a new terminal, and this is what my machine is called, Daphne 3030. And it says, what do you want to do? Well, the first thing I need to do is I need to create the appropriate environment for this to work. It's not a lot of things, but I just walk over here and I press this copy button, and we'll walk down here and paste it there. Wonderful. And then hit enter on my keyboard. Voila. And now we are in the environment that we need for this program to run. And then I simply need to turn on the program. This would be like pressing run inside a computer or double-clicking an icon on Windows. I just have to run this Python program called controller.py in Python. So again, I just copy that and run over here and right mouse click and paste it there. And when I hit this, a few things will happen. It'll start running the program. So now it's running the program and it's talking to the Arduino. If we go back and look at the program itself, you'll notice that we will notice very, very quickly that it's going to talk to the Arduino, or at least ask the Arduino, hey, do you have any new information for me? Once a second, if nothing happens. So down here, you'll notice that this board is blinking once every second or so. One, 2, 3, that little LED right there is blinking. That transmit, that is the Arduino responding to the question, hey, nothing really has happened recently. Do you have any information for me? But to actually see this happen, you'll see there's a little tiny note here that says the actual interface called UVIcorn, not unicorn, but UVicorn, is running at this address, the Hypertext Transfer Protocol. Go ahead and go there. So I happen to have this listed over here. I copy this. I'm going to run over to my other monitor, and, I didn't mean to minimize that. I'm going to paste it there. I'm going to paste and go. And there's our program. So this is our program to the user. This is the knowledge running over here on the server and running down here in reality. So what's going to happen is I'm going to attempt to turn this volume knob and see if the screen over here can follow it. And you'll notice that it is following it. And right now it's programmed to not follow it exactly, but to, again, check the board for a new value every second. So this goes from 0 all the way down to 0, if I can get it down to 0. And it should be all up to 1020 or 1024, depending on how well this this resistor is working. Fantastic. And then over here, that's sort of the input, measuring in the lab what's going on. It can be a resistor like this guy, a volume knob, or it could be a sensor. It could tell us how dark something is, how light something is, what the temperature is, all kinds of fun things. And then over here, of course, we have, keep on calling on the screen, I have a button called turn on the LED. I turn on the LED and the LED turns on. I turn it off. There's nothing to notice on the screen like, hey, wait a minute, how do I know this is actually happening? What's going to happen is I go over here to the LED and I press turn on LED. You're going to hear me click. There you go, the LED's on. So all I did was, it's a very simple user interface. I have not illuminated these buttons to tell me which one is on. Maybe in a real program we'd put a little extra indicator, but all this says is if I press the turn on LED, it should turn on the LED, not only the original LED, the real LED, there's also another LED that is illuminated on the board here. That's the sort of the testing LED. I get my thing to focus here on my hand, and you'll notice it's still talking. The server is still talking once per second. If I go back over here and I press the turn on LED again, I'm going to keep on pressing this. You'll notice that it keeps on saying, hey, I'm getting information from the web user interface, but nothing happens because it's already on. All it's doing is keeping it on. It's like walking over to a light switch and pressing it back up again. But of course, if I turn off the LED goes off. You can't see it because I wasn't looking at it. There we go, on and off. Again, both of these guys, the yellow LED for real, and the yellow LED over here on the Arduino. So this is not a lot of code. It is not a lot of programming. Again, these are still listed here. Here's the Arduino code that runs the C++ inside the board to tell it what to do and which wires to turn on and turn off. There's the control Python that actually runs the entire system and opens the server and controls this information down here. And then there's the JavaScript that actually controls this value over here. What is really neat about this is that I'm recording this at the end of May 2026, and I'm inside Google Antigravity IDE. It turns out that I have not written a single line of code. My fingers did not use my keyboard to type any of the code inside the C++, any of the code inside the Python, or any of the code inside the JavaScript. It just so happens I'm old enough that I know how to program. I know these languages. I know how to program if I needed to in C++ and Python and JavaScript. But with something like Antigravity IDE, which is an AI agentic development system, all I did was walk over here to this sidebar, and down here on the bottom where the next conversion area down here, I simply described to the AI what I would like to build. I simply needed to tell it, oh, by the way, this is what I'm working with. I have an idea of what this should probably look like. Please make it happen. And it did. It took a while to do it. I mean, we did it piece by piece, but I didn't type any of these commands. I didn't need to run out and brush off my C++, my Python, and my JavaScript. I simply needed, as a scientist, to know what I'd like this thing to do. So over here are all the files that it created. Of course, there's the Arduino C++. There's a design document that tells me and anybody else what this actually does. I click on this guy over here. This is what it tells. This is sort of the document that I made. I did not type this either. It took our conversations and said, hey, based on what Bill told us to do, this is what we did. Again, I'm giving them the royal we. And then here's the environment. The environment is how the computer should pull up particular drivers and helper programs. That's sort of often hidden over here. And then there's our web JavaScript, and then there's our controller PI. So what I can do is if I can go shut this thing down, I simply just need to close the web and close that guy out. I come back over here. It tells me that the connection has closed. However, the Python is still running. So if I were to go back over to my my Groover over here and paste that again, paste and go, it would open back up again. So what this does is not only does this work out pretty well as being a convenient way to make a user interface, these things are still working, is that I can also, if I were to configure it properly, I haven't done it yet, but if I were to configure my network, I could also pull this up on my phone. So now I don't need to actually be at this computer watching this information. I can actually control whatever laboratory instrumentation we do on my phone or anywhere else that has access to this network once I make the appropriate connections. So yeah, so there we are. So I'm going to close out of this guy, come back over here, and then to shut this thing down, it says, oh, by the way, to make this thing down, shut down this server, it's actually just a Control-C on my computer, and then I've done that. We're back to that VNVE. And I just go ahead and press this button, and we're back to where we started. So this guy is still energized, it's still popular. Of course, I could go ahead and shut down the power if I want to, but it's still available. But right now, the server is not running, and things are back to where it needs to be. And now that it's not working, if I were to want it to turn this into something larger, put extra sensors in there, or put extra what do we need me to do, or maybe some analysis, or make things pretty, I can now go back into programming mode and have a lovely conversation with the agentic Antigravity IDE. It would control all of the changes in our files in our system, and then off we go. We test it and we go. That's how things are easily done. And this is how we're going to program using Antigravity IDE and the Arduino and Python and JavaScript this summer. And I'm looking forward to it. Thanks.